Okay, introduced this section and did one example. So of course we're going to do more examples. So we have these functions f of x and g of x. They're continuous on the interval ab. Okay, and g of x is less than or equal to f of x for all x in the interval. Ooh. All right, so the area of the region bounded between these graphs. Bounded between the graphs of f and g and the lines x equals a and x equals b. Let's put the lines. Cool. So the integral from a to b of f of x minus g of x dx. Okay, so we are going to sketch the area between these two curves. Also, just a little side note, we have my fun little cat right here. Just everybody say hi to Carl, taking a nap. Okay, back to this. So you have y equals x cubed minus x. Other function is y equals 3x. Okay, sketch the area between these two curves for x equals -2 and 2. So between -2 and 2. Oh, you need some extra space. Let's split this one. Okay, this way, this way. Let's find where the lines intersect. Okay, so we'll have x cubed minus x equal to 3x. All right, subtract 3x from both sides and then factor. So, we'll draw a sketch in a second. We're going to find where the lines are equal, and then we're going to find some intercepts for each of the functions, and then put it all together. Okay. We don't need it anymore. Let's just do some scratch work. All right. Let's see. Minus x minus 3x, so minus 4x. All right. So factor. So we've got 0, positive 2, and negative 2 are places where the lines or the functions will intersect. Intersect. Okay, I did find some intercepts for y equals x cubed minus x. I got, let's see, let me see, got x intercepts, x intercepts. So you let y equal 0. And then find out what those x values are. All right, we're just gonna factor. X times x squared subtract 1. Okay, cool. Okay. So for this curve, we've got intercepts. The other line or the other curve is a line, and then we've got the place where they intersect. So let's draw the graph. And also make it we're gonna keep on trying. Sketch. 0. This highest power is odd, so it's going to do one of those odd kind of tails this way or this way. It's positive and it's odd, so it's going to go up and over. We have to go through these intercepts. So we're going to come up and then through and then up again. Let's see if I can do this. Okay. The other part is a line and it goes through the origin and the lines, this guy and that straight line intersect at -2, +2. Let's try to draw this as best as I can. Oh, that's okay. That's pretty good. And the area between them, put in this color. Okay, this one was y equals x cubed minus x. And this was y equals 3x. Okay, then I just wrote what this area for the shaded region, just between -2 and +2, what that is. -2 to 0, the top graph minus the bottom graph. This top graph is x cubed minus x. Add the area from 0 to 2, where you have a top graph being 3x, subtract the bottom graph, x cubed minus x. All right, so for here, I got 4. This integral, also 4, and then add them together to get 8. I'm just going to kind of skip all that scratch work. But of course, you can check it and let me know if I made a mistake. Okay, next. We're going to skip this one for now. Next one we're going to do, let's see if we can come back to this part. Cool. We're going to find the area of the next triangle. We're going to list the vertices. Vertices of 0, 4. Next one is at 2, -3, and then 6, 2. Let's see, some units would be nice. So let's go. 0, 4. 2, -3. 6, 2. Okay, so just keep everything organized. I called this line A. And then I call this one B. Go to scratch work. Okay, just a reminder, slope is the difference in y values over your difference in x values. Let's do y1 minus y2, x1 minus x2. Okay, let's find this equation first. So for the line A, I've got a slope of, let's see, 4 minus 2 over 0 minus 6. Oops, just 2. This y-intercept is at 0, positive 4. So the line is negative 1/3 x plus 4 for this. Is it negative? Yes. 1/3 x plus. Okay, pause. Okay. Focus on this line. B is the line with a slope of 4 minus negative 3 over 0 minus 2. So got a slope of 7, negative 7 halves. And then I use that other equation, y minus y1 equals m times x minus x1. So, and also, I hope that you were able to draw this. We're going to erase the picture for now. We'll put it back up soon. Put in your slope and one of the points. I chose the point 4 or 0, 4. So 4 here, slope there, and 0. y equals negative 7x. Oh, wait, this is good. Okay, there we go. That was line B, and now we need to find line C. Okay. Last one, slope of 2 minus negative 3 over 6 minus 2. And then I put everything into this formula again with the 0.62. And then I just solved for y. So got 5 fourths x minus, let's see, this will reduce, leaves a 2 down here, 15 over 2 plus 2. Go. I got negative 11 over 2. Also, I agree with the chat. I hope you guys are all doing all right. Hope this internet connection lasts a little longer and you can do this last example after. Find line C. And then write the area down. Okay, so if you have your picture, you want to do an integral from 0 to 2 and then from 2 over to 6. So you're going to cut the triangle. I'll show you right here. See, go here, down, over. So the top function minus the bottom function, and this will still be the top function, but minus this is the bottom function. So the integral from 0 to 2. So you start. Of line A, so guys, negative 1/3 x plus 4. I don't know if this will work. Okay. Minus line, what was this, B? Which was negative 7/2 x plus 4. Then add the integral from 2 to 6. Of the top function. Minus the bottom function, which we called C. 5/4 x minus 11/2. And dx. Okay, and then it didn't actually find the number, it just wrote that you would combine like terms and then integrate. So just etc. Oh. me make sure I see. Why do you choose 6 and 2? So just to draw a little bit and talk about what happened. So my triangle was at 0, 4. The 0.23. And then over 60. Okay. So the definition of the area between the two curves is to take the top function and then subtract the bottom function. And there's a place right here with there's a new function. Oh, that was a previous part. Okay, we're all good. So 0 to 2. Then you have a switch from 2 over to 6. And I think that we have time to do one more problem. Let's see. Okay, this one's a little tricky. Everything is drawn with respect to y. And I don't know if I'm going to put stuff like this on your homework, but I think it's still worth talking about. And it's the last thing I have for today. So if we don't finish it, we can always try again next time to find the answer, and then we'll do like review and backtrack. Okay. Let's start. Okay. We're going to do this. X equals negative y squared plus 12 over 4. Okay. Or, yeah, it's fine. Okay. And then the other one is x equals y. All right, so I just want to put a side note. First, I thought, oh, look, this is I guess you call it a sleeping parabola. And it's a negative y squared here. But I also checked with Desmos, so just note that I used Desmos. Which I don't want to rush through this problem. So let's get some stuff set up. We'll come back next time and we will use Desmos together to get the sketch. And then we'll talk about the area after that. It will take, 2 pages of work. So this will write as x equals negative 1/4 y squared plus 3. And then we'll draw this graph using a graphing calculator. We know how to draw this graph. It's pretty easy peasy. And then while we have 4 minutes, so we'll leave this for later. I want to talk about a little bit of stuff that's going on in the background that we haven't really talked about in this class, and I don't know if the book will ever bring it up. I don't know how well I can explain it, but let's give it a try. So when we are doing these integrals, what kind of happens is we're taking slices, and that's the whole point of the next section, is to do a lot of specific slices. But let me draw a picture of this kind of thing. What did we do? Back here, And we had that sketch. Looks like this. And we want it like this. So when we're doing an integral, we find a little slice like this little rectangular area here. You may have seen this before too. This little width, which we call a change in x, delta x. So little x sub I minus x sub I minus 1. And then what we do is take infinitely many slices and just fill this up. So that's what the integral is the limit of all of the slices. And I wish I had written that down precisely what this is, but something like, I'll get it next time. Anyway, what I'm trying to get at is the next problem we're doing, we want to do slices the other way. So you have a picture with a parabola like this. Let's just leave it like that. And we want to find, the area of the shaded region, but we're going to take a slice this way. There's a little change in y, we call it delta y. All right, I think I'll try to explain it again next time, and then we'll do this example. And then I guess we'll put the next section on pause and do a review. Maybe we'll go back to, what's this? Okay, so anyway, we'll do a review Wednesday, then we'll come back and we'll probably finish chapter 6 on Friday. All right, have a good day, everybody.